Hello everyone, my name is Maroan Elgallal and today I'm going to present the topic of influence of integrating wrapper waste on earthen construction Adobe properties. Here we have the presentation outline which will start with a brief introduction, then literature review and material and methods. And also we will have some of the test results that we applied up to now, and also we will have conclusion. In introduction, we can say that earthen construction is getting more popular in recent years due to the fact that it has the ability to provide sustainable and environmentally friendly buildings. Also, one of the key elements of earthen construction is the alkyd, which consists of sand and clay mixture with a specific proportion of gypsum and lime. For problem statement, we can mention that alkyd might form significantly rigid material if the percentage of lime and gypsum is adjusted, but the mechanical and dynamic properties of alkyd can be enhanced by adding waste rubber to the mixture, where this can be minimize the environmental impact of waste rubber, since they will be used as recycled materials without any extra treatment. For literature review, current study regarding the earthen construction Adobe investigated the influence of incorporating the uh, polypropylene fiber, straw and plastic fiber with minimal percentage, as the case of Benji 2005, Donker in 2015, and Ahmed in 2021. On the other hand, Bakirolo Balkis in 2017 was the first to include waste in the production of earthen construction, where she used the waste marble dust and found that it enhanced the strength significantly when 10% is added to the mixture. For the material that will be used, we have a sand clay that can be collected from sites in order to check their property, where in our case we will collect them from Famagusta city. Also, we have gypsum and lime powder that can be found anywhere from local suppliers. Then we have the waste wrapper, which can be used in different shapes, such as fine particles, powder, or even fibers. And here we have this flow chart which explains the methodology of the research, where we will be selecting the materials such as sand, clay, gypsum. Then we will calculate the water content, and we will replace the sand clay mixture with rubber waste from 0%, which is the mixture without rubber, up to 40 or more, to evaluate the compressive strength, tensile strength, flexural strength, material damping, and evaluate the unit weight shrinkage. Then we will select the optimum. Also, rubber fiber, we need to consider the L/D ratio, since it affects the results, and scanning electronic microscopy should be used to find the microstructure characteristic of rubber. However, rubber is recycled material. We need to find the chemical composition and how it reacts with other components. Also, we need to do some economical analysis. For the economical analysis, feasibility investigation will be done to compare the cost of this alternative material. Many things can be considered to find the economical results of this material, such as the cost of labor, transportation, skills needed for workers, and so on, just to compare the cost. Also, we have done some tests, and here some of the results that we obtained up to now. So in order to estimate the best amount of molding water mass, an experimental program should be designed. And here we prepare some samples with different water and clay contents, while the gypsum and lime percentage were adjusted 10% and 2% respectively. And we found that 12.5% of water in the mixture and 10% of clay are giving the highest compressive strength compared to others. Also, we have calculated the unit weight. For the unit weight of samples that has a wrapper, it was recognized that whenever percentage of rubber is increasing, unit weight of the sample is reducing, as showing in this graph. Also, the compressive strength is reducing when the rubber percentage is increasing in mixture, which might be attributed to several factors such as adding the rubber reduces the workability of specimens, causing the followed manual compaction to be ineffective. Also, the rubber is an inert material and does not react with water, which increases the amount of available free water in the mix. Also, rubber particles are more compressible in compression in comparison with the sand particle. It should be studied more. This should be studied more and more to find the acceptable compressive strength that mixture can provide. And in conclusion, we can say that this presentation addresses the new sustainable construction material to be used in the region with a high seismic activity. This will be achieved by incorporating shredded tire wrapper waste into an earthen construction material to produce lightweight material with energy dissipation properties. In order to achieve this project, testing program is proposed to investigate the optimal uh, proportion of the mixture. And here is some of the references that I have used in my presentation. And thank you for your attention.